Hi, welcome back. So 2.4 is just an extension of 2.3 where we're still talking about set operations and Venn diagrams, but now instead of two sets, we're going to have three. And the best way to do these is to just go jump into examples. So I'm going to do a few with this example 1 on page 19, in case you're wondering where I'm at right now. And I'm going to look at A first, and I have A union B intersects C. Okay, so the first thing we want to find here, we want to find B intersects C. And what does that entail? Okay, B intersects C, those are the things that they have in common, which are B and F. Okay. Now we want to look at A union with my B intersects C, which I've already found. Okay. So my elements in A are A, B, C, D. B is already in set A. And so my solution to this one would be A, B, because it's in both of them, C, because it's in A, D, because it's in A, and F, because it's in B, intersects C. Okay, so you want to just do these the same way. You want to do them in pieces. If there's a parenthesis, take care of it first. If there's a parenthesis and then a complement, you take care of that first. You do all those things first. Okay? I'm going to go ahead and look at part C. Okay, so I have A intersect, B union, C complement, but notice the complement is on the inside on the C. Okay, so the first thing I want to do here is I want to find my C complement. Those are all the items in the universe that are not in C. Okay, so that would be A, B is in C, C is in C, D, and E. Okay, so start there first. Then go ahead and take care of B union C complement. Okay. B union C complement, okay, is going to be all the elements in B and the ones that are in C complement. So I have A because they're in both, B because it's in set B, D because they're in both, E because it's in C complement, and F because it's in B. Okay. Now I'm going to go ahead and put it all together, and I want to go ahead and take A and find where it intersects with my set B union C complement. Okay, so what do they have in common at this point? Okay, they have A has an A, so does B union C complement. They both have a B. This one doesn't have a C, so no C here, but we have a D, so they both have a D. And we're out of elements in A, so there's nothing else that's going to be in common. So this one is going to be A, B, and D. So it really works exactly the same as it has been working for one set, except that we have to do a few more steps and go ahead and put those all together. Okay, so a little bit more work, but not a whole bunch. Part B, you just have to find the unions of each piece first and then put them together as an intersection. So it should be pretty straightforward, but if you have trouble and struggle, give me a holler. I can work it out for you and send it to you, or help you along with it during one of the office hours. Okay. Another thing I want to look at is we do have to construct our own Venn diagrams. Okay. And in order to do this with 3 sets, what we want to do is we want to start with the innermost elements. Okay. And this is what this means. You could look at what it has out there and it might look confusing. We want to look what's in all sets. So is there in all sets, is there something in common for all 3 sets? Okay. Do that first. Then look at in A and B. Find out what they have in common. A and C, what do they have in common? A and B, look at what they have in common. And then look at what you haven't used in either of those sets. So then look at set A minus whatever they have in common. Okay? And then set B minus whatever they had in common with another set. And then C. So those elements will be just only in that set. Okay? And then any leftovers that doesn't belong to any of those go in the universe. Okay? So what you want to do is you want to start, it's like a flower. You want to start inside the center and then start blossoming outward. Because it's much easier to find what things have in common with more things than try to figure it out later. And this is going to be real important in 2.5. I can't even stress this enough. That in 2.5 you're really going to need the skill of being able to work inside to outside. So let's go ahead and look at an example. Okay, I've already drawn the Venn diagram. Okay, there's nothing inside of it. But notice when I'm talking about petals, I have an inside piece right there, right? And then I have 3 where 2 sets have in common. And then I have the sets themselves. And then I have my universe. So I'm going to go ahead, first of all, label my universe and my sets. I'm going to call this set A, set B, set C. Okay. You can label in the circle or outside the circle. I guess it's really up to you as long as I know which set is which. The first thing I want to do is I want to find the elements that are in A, B, and C. So I'm going to look for the center piece here and find what numbers they all 3 have in common. Okay. Go with one set, start through. So A, they don't all have 1. I have a 3 in A and C, but not in B. I have a 6 in A and not in B and C. But, well, the only thing I seem to have, and I have a 9 in B and C, but then the only thing I really seem to have in common here in all 3 is this 10. Okay, so in this center petal, that is where my 10 is going to go. And I'm not going to worry about this anymore. Okay, I've already taken care of that. Now I'm going to go ahead and look at A and B. So I'm going to look at this section here. It really doesn't matter the order you go in, guys, but that's a section I'm going to look at, okay? And so in this section here, I want to look at what A and B have in common only. Okay, so if I go ahead and look, A and B have absolutely nothing in common. There is not one thing left over in both A and B. Now remember, the 10 isn't common in all 3. We don't count that. That's why we took them out. There is nothing in common here. So there's a big 0. Okay, now let's go ahead and look at, let's do B and C. Let's do this section right here. Okay, so now I want to look for items that are common to both B and C. Well, if I look at B, they both have a 4, and they both have a 9. So in this section here, I'm going to have a 4 and a 9, and I'm going to take those guys out of the picture. Okay, so notice I'm crossing them out as I go ahead and do them. Now I'm going to look at A and C, this section right over here. Okay, so what do A and C have in common? Well, they both have a 3. And that looks like it's it. So in this section here, we're going to go ahead and put a 3, and we're going to take that out. Now, as you're going along, you can also take them out of the universe too. I didn't really talk about that, but you could take the 10, the 9, the 4, and the 3 out of the universe too. So you know what's left over in your universe. It's totally up to you. Okay, now elements that are only in A. All right, elements that are only in A are 1 and 6. So 1 and 6 also come out of the universe. Items only in common in B are 7. 7 also comes out of the universe. Items only for C are 5 and 8. And those come out of the universe. And then what we want to do is we want to look at our universe. And we want to see who's left. Well, I have a 2 left. And that looks like it's it. So in my universe, there goes my 2. And I'm completely done with my Venn diagram. Okay, so the big thing you want to do is make sure that you start in the middle with that 10. Then slowly flower yourself out until you finally get to universe and cross things out along the way. That's totally okay. All right. I left another one for you to go ahead and try. I didn't want to do both of them. So go ahead and check it out. See if you can go ahead and create your own Venn diagram. And again, if you struggle with that, please go ahead and send me an email, and I'll go ahead and help you out with that. We got one more topic in this section I want to talk about. All right. And this is something that proves 2 sets are equal. And these are equality of sets. Now, De Morgan's laws also apply to other things. Right now, we're just going to worry about just the way it works with sets themselves. Okay? And what De Morgan's laws are, if I have A intersect B complement, that is equal to if I have A complement union B complement. If I have A union B complement, that is equal to A complement intersect B complement. Okay, so the complement of the intersection of 2 sets is equal to those 2 sets. Okay. De Morgan's laws is something that applies to a lot of different things. They apply to sets and other things. But what you want to do is if it's in parentheses with a complement, it's going to be the opposite operation, and each piece is going to have its own complement. So it's kind of fun. In that case, it's where you just kind of split it up, but you got to make sure to change your sign. Kind of like when you use inequalities, move a negative over, you have to change your inequality sign. Kind of the same idea. Right? So I go on ahead and do one example of De Morgan's laws. And this is example 5. I've already got it drawn out for you. And I want to look at what region is A union B complement. Well, A union B complement is equal to A complement intersect B complement. Okay, so what's not in A, what intersects what's not in B. All right. If we want to go ahead and look at this as it is, you can see that if I have A is equal to regions 1 and 2. B is equal to regions 2 and 3. Their union is 1, 2, and 3. Therefore, their complement is going to be 4. It's going to be the universe. Okay. And remember, it's like the union of them, and you can look at that. The union of these is those things, right? It includes one or the other or both. Okay. So what is not those is the universe. So you could have done it a lot quicker using De Morgan's laws. Okay. If I want to look at A complement, intersect B complement. Okay, it is the exact opposite of what we just did. So it's also going to be section 4. Because we already did it. Now we're going this direction. Okay, and this helps prove that A union B complement is equal to A complement intersect B complement. And you could figure these out separately, okay? You're going to find out that A complement is 3 and 4. B complement is 1 and 4. And their intersection is 4. Okay, so this is all I have for this section. The next section is 2.5. I may break it into 2 videos because the last example gets really lengthy. But if you have any questions, go ahead and send me an email, and I'll see you in the next section.